The last thing we're going to talk about in this lesson as it relates to linear equations is how we can write equations of lines that are perpendicular or parallel to a linear equation. So a couple of things about perpendicular lines and parallel lines. So let's talk about perpendicular lines first. So if I have an x and y axis, and somewhere in that x and y axis I place perpendicular lines. Perpendicular lines are lines that meet and form right angles. And something interesting happens to those linear lines or linear equations when they form perpendicular lines. If they are perfectly perpendicular, that means they form right angles. And when they form right angles, something interesting happens between their slopes, okay? So one of the things that you should notice about these two lines, let me just number them, 1 and 2. Line number 1, you should recognize slopes upwards. So the first thing you should recognize is that one of them is positive, and look at the second one. The second one falls down. So on all lines that are perpendicular, you're going to have one positive slope and one negative slope. Okay, so these slopes are opposite signs of each other. The other interesting thing that you can't really tell from this, but if I were to show it to you, if you were to look for the slope of these lines, the difference between their rise and their run, and if I actually had values in here, what you would find interesting is that when you take a line and then you rotate it 90 degrees so that way it forms a line that's perpendicular to it, the slopes, the rise and the run of the slope actually switch places. So for example, if it was 3/4 was the slope of line 1, when you rotate line 1 this way to form line 2, it actually reverses the rise and the run. So it becomes 4/3, and then of course it's a negative slope, so it's negative 4/3. So what you should recognize about the slopes of perpendicular lines is that they are opposite of each other, which means one's positive and one's negative, and they are reciprocals. Reciprocals just mean flip the fraction, switch the numerator and the denominator. So what you get is two fractions that are reciprocals of each other, and one is positive and one is negative. So if I were presented with an equation, something like this, and I was asked to tell what would be the slope of a line that is perpendicular to it, well, the slope of the current line is -3/1. So what would be the reciprocal? Let's just do this. Here's a negative. If the slope is perpendicular to that, first of all, it's going to change to a positive, and then it's going to change to a reciprocal. Well, the reciprocal of -3/1 would be positive 1/3. The 3 and the 1 switch places, and it becomes the opposite sign. So if it was already a negative slope, then the slope of the line that's perpendicular to it is going to be a positive slope, and it's going to be the reciprocal. So these would be the reciprocals. Now, the y-intercept is going to be different. In just a minute, we're going to do an example and learn how we can write a line that is perpendicular to another line if it passes through a different place. And so then we're going to have to use some other steps in order to be able to figure out what this rest of this equation is. But right now, I just want you to be aware of the fact that an equation, two equations of linear equations that are perpendicular to each other, they are going to have slopes that are opposite reciprocals. Now, parallel is a little easier and should make logical sense to you. If two lines are parallel to each other, that means they never cross. So if I'm looking at a coordinate plane and I graph two lines on that coordinate plane that look to be parallel to each other, what you should recognize is their slopes stay consistent, okay? If one of those lines was more slightly sloped than another, either positively or negatively, those lines would eventually meet. So if this one, for example, was just a slightly bit more sloped, like this, eventually somewhere over here, they're going to cross, okay? So what that should tell you is that in order for two lines to be parallel to each other, they have to be the same slope. So perpendicular lines have opposite reciprocals for their slopes. And parallel lines have the same slope. Now, they're going to cross the y-axis in different places. You see a point here and a point here. So if I were to write two equations that would be parallel to each other, you're going to see that this part is going to be the same. The only thing that's going to be different is the y-intercept, okay? Because they aren't the same line. One of them is slightly above the other, okay? So you're going to see the slope the same, but the second number is going to be different because they're going to touch the y-axis in different places. So you're going to see that as we get into some of these examples on the next page. So I'm going to pause the video right here just to kind of go through and explain to you what the slopes of these types of lines look like. Now we're going to do some examples of each one.